Hello friends, welcome to edupediaworld.com. So in the previous video we talked about motion. We studied what is motion, what is speed, what is velocity, and we also solved few of the numericals which are related to motion. Now in this video also we are going to learn new terms, and one of which is acceleration. We are also going to talk about the three equations of motion, and within which we will discuss what is the equation for velocity time, that is, what is the relation between velocity and time, what is the relation between distance and time, and position and time. Right, and thereafter we are going to solve the numericals which are based on the equations of motion. So now we studied about uniform and non-uniform motion in the last video, and what we talked is that in uniform motion, what happens? Uniform motion is that the car or a person is traveling equal distance in equal intervals of time. So that is uniform motion, right? In this case, the velocity is going to be constant. The velocity is not going to change. So which means that the rate of change of velocity will be zero. There is not going to be any change in the velocity, right? Whereas if we talk about non-uniform motion, what is the definition of non-uniform motion? Non-uniform motion means the car is traveling unequal distances in equal intervals of time, right? So in this case, why is the car traveling unequal distances? Maybe because the speed is varying, right? The velocity is different. Velocity is not remaining constant during that interval of time. So that means the rate of change of velocity has some definite value. It is not zero like it was in the case of uniform motion, right? So the difference between uniform motion and non-uniform motion is that the rate of change of velocity in uniform motion is zero, whereas the rate of change of velocity has some definite value when we talk about the non-uniform motion. Now, over here, we can define this rate of change of velocity by a term which is known as acceleration, right? So we're going to discuss what is acceleration, but let me first explain to you in very simple words. Right, let's say there is a body, and the body, let's say a car or a person or a truck or anything, this particular body is moving with unequal distances in equal intervals of time. Right, and let's say that for the first 30 minutes it travels 10 kilometers, next 30 minutes it travels 50 kilometers, and in the next 30 kilometers it again travels 100 kilometers. So what is happening? The velocity is not constant. The velocity is first of all changing, and the velocity is increasing. So the body is said to be in your non-uniform motion, and it is accelerating. Right, so acceleration is related to rate of change of velocity. So let's first define acceleration. Acceleration is a measure of change in velocity of an object per unit time. Right, so the formula for acceleration is change in velocity per unit time, that is divided by the amount of time taken. That will give us the acceleration. Now, let's say if the velocity of an object changes from an initial value u to a final value v in some particular time t, let's say t is the time. So in this time t, the velocity of the object changes from u to v. So in that case, the acceleration can be calculated as the final velocity minus the initial velocity divided by the time. Why do we say final velocity minus initial velocity? Is because this will give us the change in the velocity, right? And this can be calculated for any given time interval, right? So that is how we calculate the acceleration. Unit for acceleration is meter per second square, because see, what is velocity? Here on the top, the velocity is meters per second, and this is again time is again in seconds. So when this time comes up, it will become meters per second square. right? So acceleration is given by a is equal to final velocity minus the initial velocity divided by time. Now there is one thing which you all must know. The acceleration can be positive as well as it can be negative. When can it be positive? When the acceleration is in the direction of the velocity, it's called a positive acceleration. And when the acceleration is in the opposite direction to that of the velocity, then it is known as negative acceleration. So you are going to understand about acceleration when we carry out few numericals. So then you will understand what is positive and what is negative acceleration. I will give you an example for positive and negative acceleration. If a car starts and it is going to increase its speed, so in this case the acceleration will be positive because the car is continuously increasing its velocity, so the acceleration is positive. Whereas let's say the driver suddenly applies a brake, so it's going to come to a stop, so in that case the acceleration will be negative, right? So now let's check out few numericals, and with these numericals you will be able to understand more clearly as to what is acceleration. So the question is that starting from a stationary position, Ram pedals his bicycle to attain a velocity of 6 meters per second in 30 seconds, right? So with the first sentence, first of all, we should understand that the cycle was stationary and then ultimately it attains a velocity of 6 meters per second, right? So what we have, we first have initial velocity with us. We know initial velocity was 0 because the cycle was stationary. Final velocity it is clearly given as 6 meters per second. And time is given to be 30 seconds. Then he applies brakes such that the velocity of the bicycle comes down to 4 meters per second in the next 5 seconds. Now calculate the acceleration of bicycle in both the cases. So first we'll talk about the initial case, and as I have written and we have studied that the acceleration is final velocity minus the initial velocity divided by time. So in the first case, the final velocity was 6 meters per second because the cycle started from the stationary position and it attained a velocity of 6 meters per second. So 6 is the final velocity minus 0 because the initial velocity is 0 divided by 30 seconds. So what we get is 0.2 meters per second square, right? This is in the first case, the acceleration will be this. So that means the acceleration is positive. Let us see in the second case what are our final and initial velocity. Now, because the bike is already in motion, the initial velocity becomes 6 meters per second because 6 meters per second was the final velocity for the first case. So this becomes now our initial velocity. And then it says that the velocity of the bicycle comes down to 4 meters per second. That means it is decelerating, right? In the first case, it was accelerating. Now in the second case, it is decelerating. And the time is given as 5 seconds here. So now in this case, we know that the initial velocity is 6. The final velocity is 4 meters per second and time is 5 seconds. So when we substitute all the values in the given formula, then we get 4 minus 6 divided by 5 will be minus 0.4 meters per second square. So because we have a minus sign here, this shows that it's a negative acceleration. Even without solving this problem, just by looking at the problem, we can say that when is it a positive acceleration and when is it a negative acceleration. Because in the first case, the bike started from 0 velocity to 6 meters per second, it is acceleration. And thereafter, from 6 meters per second, it comes down to 4 meters per second. So that is deceleration. It's a negative acceleration. Now I'm sure you will understand the difference between positive and negative acceleration. Now let's talk about what is time distance relationship. There are various relationships that we'll be talking about. Time distance, then we have position and time relationships. So with all these relationships, we will come down to what are known as the equations of motion. Now when we draw the graph of time and distance, let's say we have time on the x-axis here and distance on the y-axis. If we take a case of a non-uniform motion with equal intervals of time, the velocity is also remaining constant and there is no rate of change of velocity. The graph that we will be getting is a linear graph like this, right? Graph is going to show us a slant line like this. It's called a linear graph, right? Whereas if we consider a case wherein the object is moving with non-uniform motion, that is unequal distances in equal intervals of time. In that case also, if we take time on the x-axis and the distance or the displacement on the y-axis, then the graph that we are going to get is again a similar graph. The only difference is that this graph is not going to be a proper linear graph like it was in the case of a uniform motion, but it's going to not start from this point 0. This is for a non-uniform motion. So with this graph, let's say we consider again the uniform motion wherein the object is moving with uniform velocity. How are we going to calculate the velocity in this case? We have the time and we have the distance. How are we going to calculate the velocity? Let's say we have the object was, let's say here, the first red dot that you see is the initial position of the object and the final position of the object is, let's say, this. So at this position, let's say the object completes a distance of, let's say, 10 meters. S1 is, this is the distance. S is the distance and T is the time. So S1 and T1 are the distance and the time of the object in this position. Later on, it completes a distance of, let's say, this is 20 meters and now the time is, let's say, 2 seconds, right? So on the graph, we plot the points like this. Now we have all the 4 values with us. So the velocity will be equal to S2 minus S1 divided by T2 minus T1, right? That is difference in their distances divided by difference in the time, because distance upon time is velocity. So that is how from the graph itself, from the time and distance relationship graph, we can determine the velocity. Next, we are going to talk about velocity-time relationships. So why are we talking about these relationships? Because these will lead us to what are known as the equations of motion. We should know what are the relationship between all these terms. Now, what is the relationship between velocity and time? Again, we will discuss both the cases. On the left-hand side, what you see here is the case wherein the object is moving in a uniform motion, right? When the object is in the uniform motion, the velocity is constant. It is not changing. That's why if we have time on the x-axis and velocity on the y-axis, so after 30 minutes or after another 30 minutes or after the next 30 minutes, the velocity is remaining constant. It has a constant value, and that's why we see for a uniform motion, the graph is going to be a horizontal line, right? There are no ups and downs in this graph. It's a horizontal line. Whereas if an object is moving in non-uniform motion, that means sometimes the velocity is increasing and at some other time the velocity is reducing. So the graph is going to be zigzag. So right. So as you see here, this is, let's say, the time in seconds. So for the first 3 seconds, the velocity was increasing. The next, from 3rd second to the 5th second, the velocity remained constant. Again, from 5th to 7th seconds, it was again increasing. And thereafter, after the 7th second till about the 10th second, the velocity was again reducing. So because it's a non-uniform motion, right? So that is how the graph is going to be for the velocity and time relationship. Now, in this velocity-time relationship, let's say we have an object which is in uniform acceleration. Now, what do you mean by uniform acceleration? That the acceleration is uniform. That is, the acceleration is the same. Acceleration remains constant. That means the rate of the change of the velocity is constant, right? It has a definite value. So that means the velocity is changing. Velocity is not constant now. The velocity is changing, but at a uniform rate. Let's say now the velocity is increasing, as you see here. With time, the velocity is increasing. So the graph is going to be similar to what we saw in the distance time relationship in the case of a uniform motion. So now in this case, what we do is AB is the line that we are going to get. This is a linear graph that we are going to get, right? So what we do is that on the x-axis we have OC is the time, and we draw a dotted line parallel to OC, which is A and D, right? Another B is the final position of the object, A is the initial position of the object. So U is the initial velocity of the object, and the final velocity of the object is, let's say, V, right? And T is the time. So now, in terms of the x-axis and y-axis, how do we designate the initial velocity? I said initial velocity is U because the object started with this velocity. So what is the magnitude of the velocity? OA will be the magnitude of velocity, initial velocity. And final velocity will be this BC, because this is the velocity that it attains after reaching at position B. So BC will be the final velocity, right? And what is time? Time will be this x-axis, that is OC will be the time. We know that BC, that is this final velocity, is equal to BD plus DC. So we substitute V in place of BC because this is the final velocity. BD will remain BD plus DC is equal to OA. That's why we substitute OA over here. But what is OA? OA is the initial velocity. So let's see, we have V is equal to BD plus U, that is the initial velocity. So what we get? We also know that acceleration we studied is change in the velocity divided by time, right? So what is acceleration? It is what is change in velocity here. Change in velocity will be the final velocity minus the initial velocity. So what is final velocity? It is BC minus this initial velocity, which is DC, right? So A is equal to BD by T. So that's why I get BD is equal to AT. So I get two equations here, right? And I substitute this value of BD in first equation, in this equation 1. So what I get is final velocity is equal to U plus AT, that is initial plus acceleration into time. This equation is one of the equations of motion, right? So that this is the derivation of the one of the equation of motion, which is final velocity is equal to initial velocity plus acceleration into time. And this equation has been obtained by the velocity time relationship, right? Now let's move on to the position time relationship. Again, we are going to consider the same situation wherein the object is moving with uniform acceleration. So we will consider the same graph here, right? And of course, the initial and the final velocity plus the magnitude of the time will also remain the same as it was in the earlier case. Now we know that the distance traveled by the object will be basically the area which is enclosed within this O, A, B and C, right? The area within this O, A, B and C will be the distance that is traveled by the object. Now this entire area OA, B, C can be divided into two. That is, first is area of this triangle, which is A, B and D, and secondly the area of the rectangle here. This area of the rectangle, that is OA, D and C. Now what is the area of this triangle, that is A, B and D? Area of triangle is half into, this is the base, that is AD, into the height is BD. So that is the formula for calculating the area of the triangle. So we write BD into AD divided by 2. Plus, what is the area of rectangle? Area of rectangle is AD into AO. So this is AD into AO. So what we substitute is, in place of OA, we substitute the initial velocity because this is the initial velocity. In place of OC and AD, we substitute T because that is the time. And in place of BD, we write AT, right? Now, if we substitute all these values, we will get S is equal to UT plus half AT square. So this is again one of the equations of motion. And this S is equal to UT plus half AT square, this tells us what is the relation between the position and time, because with this graph we can calculate where is the object. That is the position. This is S. S is the position. Now, position velocity relationship. So we are going to determine now the third equation of motion, again by considering the same graph, and what we do here, we consider the same area, that because this is the distance that is traveled by the object, and that will be equal to again the area of this entire OABC, entire trapezium, right? So another way of calculating the area of OABC will be, we write these two, OA plus BC into OC. So this also becomes the area of this trapezium, right? Now again we substitute the similar values in this formula, and we get S is equal to U plus VT divided by 2. Now we also know that from the velocity time relationship, we saw that S is equal to the difference in the two velocity, that is the final minus the initial divided by the A, right? So now if we substitute this value in 1, then we get S is equal to V plus U into V minus U divided by 2A, and that comes to be V square minus U square divided by 2A, right? So this is our third equation of motion, which says that 2 into acceleration into the distance is equal to square of the final velocity minus square of the initial velocity. So this is the third equation of motion, which is derived from the position velocity relationship, because here we have the position, that is S, and then we have the velocity, right? So now we know how the three equations of motions have been derived using the relationships between position, velocity and time. So what we have now are the three equations of motion. V is equal to U plus AT, S is equal to UT plus half AT square, and 2AS is equal to V square minus U square. So any body which is in uniform motion or non-uniform motion will have to follow these equations of motion, right? So now we are going to solve some of the numericals so that it is very clear to us as to how these equations get applied onto actual situations. So let's check out the first problem. A train starting from rest. So that means, what do we have? What information do we have from this statement is that there is a train which starts from rest. That is, the initial velocity will be 0. Attains a velocity of 72 kilometers per hour. That means the final velocity now here will be 72 kilometers per hour in 5 minutes. So from the first sentence we can derive these datas. Now next, assuming that the acceleration is uniform, find the acceleration and the distance traveled by the train for attaining this velocity. So first we will write what is the given data, and as I said, the initial velocity is 0, final velocity is 72 kilometers per hour. So now this kilometers per hour we are going to convert it into meters per second, because all our units will be in meters per second. So when we convert, we will get 20 meters per second, and the time is 5 minutes. So again it is given in minutes. We need to convert it to seconds. So 5 into 60. That becomes 300 seconds. Now we know that acceleration, we need to calculate the acceleration, and we already know that acceleration is change in the velocity divided by time. And what is change in velocity? Final velocity minus the initial velocity will give us the change in velocity. So if we substitute these values, we will get 20 minus 0, because 0 is the initial velocity, divided by 300 is what we get as 1 by 15 meters per second. So the train starts from 0 kilometers per hour and it reaches a velocity of 72 kilometers per hour. That means it is accelerating, and the acceleration is positive acceleration. So we get acceleration is equal to 1 by 15 meters per second. So this is the acceleration. So first part is solved. Now let's calculate what is the distance traveled by the train for attaining this velocity. Now here we have to assume that the acceleration is uniform, and now we have to calculate what is the distance traveled. Again, we apply equation of motion, which is 2as is equal to v square minus u square. And we know that in this case also, initial velocity was 0. So when we substitute the value of u in the equation, we will get 2as is equal to just v square, right? So s is equal to v square by 2a. And when we substitute the value of v and a in this, we will get 3000 meters, which is equal to 3 kilometers. So if this is the acceleration, which is a uniform acceleration, with this acceleration, the train will be able to cover or travel a distance of 3 kilometers, right? Now, let us also see another problem. It says that the car accelerates uniformly from 18 kilometers per hour to 36 kilometers per hour in 5 seconds. So again, we have the initial and the final velocity and also the time. Calculate the acceleration. So this is also very simple. We have v minus u by t, which gives us 10 minus 5 by 5, which is 1 meter per second. So this is a positive acceleration because it accelerated from 18 kilometers per hour to 36 kilometers per hour. Also, we need to find out the distance covered by the car in that time. So the formula of this is s is equal to ut plus half at square, right? And when we substitute the value of u and t and again the acceleration what we calculated from the part 1, which is 1 meters per second, we will get s is equal to 37.5 meters. So these are pretty simple, right? So now you know how to use the equations in the situations. So this is probably the last problem that we are considering. The brakes applied to a car produce an acceleration of 6 meters per second in the opposite direction to the motion. So that means this acceleration is a negative acceleration because it is opposite to the direction of the motion. First of all, we have the value of acceleration and we know that it is a negative acceleration. Now, if the car takes 2 seconds to stop after the application of the brakes, calculate the distance it travels during the time. So what are the data that we have with us? A is minus 6 meters per second square. Time is 2 seconds. And the final velocity is 0 because it says that it applies the brake and the car comes to a stop. So we know that the final velocity is 0. Now we are supposed to calculate the distance. So we know v is equal to u plus at. Now understand this thing that here we cannot use the formula which has distance in it because we are not being given any value of any distances as to how many kilometers or how many meters does it travel. So we cannot use the formula s is equal to ut plus half at square. Neither can we use the formula of 2as is equal to v square minus u square. The only formula that we can use is v is equal to u plus at, right? So when we substitute the value, we will get the initial velocity is equal to 12 meters per second. Now we know that s is equal to ut plus half at square In this formula, if we substitute the value of u, that is the initial velocity what we have just derived here, we will get distance is equal to 12 meters per second. So now we know the distance, that with this initial velocity, if brakes are applied, then in 2 seconds it will travel 12 meters. So that's how we apply these equations. So I hope you must have understood how the three equations of motions have been derived and how these equations of motions generally are applied to the situations, right? So thank you for watching Edupedia World videos.